Hey guys, welcome back to my channel. And today we're going to do some math problems. So let's get into it. So today's lesson is called Point the Way and it's 2.10. And what we'll be doing today is finding patterns that are useful in writing equations for linear functions. And these are the questions that you should be able to answer by the end of this lesson. Are there different ways to write the equation of a line? And what does each part of an equation tell us? So, man, Ms. Johnson, you already taught us this, or we already knew this from the year before, but this is basically y equals mx plus b, right? Yes, and there is an and here because there's other forms of this equation that are really useful. And so I want you to think about think about water, right? Water comes in different forms. There's liquid water, there's frozen water, and there's like steam, which is kind of like the gas of water, right? Or the gas form of water, right? And yes, and there's agua. Very good. So each of those forms are useful depending on what you are given or depending on what you're trying to find. Does that make sense? So Ms. Johnson, this is something random that you should all know. Ms. Johnson loves cold water. Like, I like water. I really, really like water, actually. But if it's cold, I'll drink a lot of water. And then so I've passed that on to my own children. And it's very, very interesting because like at one point they're like, I can't drink this. I'm like, why not? They're like, because it's not cold. I'm like, oh, geez. So my whole point is that it's the same thing, but in different forms, and it's useful in its different forms. All right, let's go. It says, Grandma Billings is making a quilt and piecing together a number of blocks. Zach and Sion are, I don't know how to say this person, Sion, are watching and thinking about predicting the number of quilt blocks in this pattern. So So here's the pattern. It goes this, and then it goes this, and then it goes this, and then it goes this. Zach says, I noticed that 2 blocks are being added each time. I thought it would be easier if I had the y-intercept. So I imagined what pattern 0 would look like by subtracting 2. Remember how our friend always goes backwards? That left block at x is equal to 0. So I wrote down b equals to 2n plus 1. So at this, that's so funny. So at this point, I want you to think about what the 1 represents in our whole thing and what the 2 represents in the whole thing. Yeah. What does this 1 represent in this whole pattern? Not just pattern 1, but just like the whole pattern. Where do you see the 1? And where do you see the 2? The 2 is actually pretty interesting. Yeah. The 1 is your starting point. It would be your original block for pattern 0, right? Right? And the 2 is the growth. So from here to here, right? From here to here, we added 2. And then from here to here, again, we added 2. Now here are the 2 that I saw added to the previous. And then here, the 2 that I saw added were these 2 on the outside, and so on and so forth. So Sion says, I also noticed the pattern was growing by 2 each time. I saw that pattern 1 just had 3 blocks. Pattern 2 has 3 blocks plus 2 groups of 1 block on either side. Pattern 3 has 3 blocks plus 2 groups of, so here's 1 group, here's another group of 2 blocks. So 2 groups of 2, 2 groups of 2. So I wrote b equals to 2 times the quantity of n minus 1. Wait, what's n minus 1? Oh, if we're at 3, n minus 1 would be, yes, it's today minus, very good. You guys remember this. So it's today minus 1, which would be yesterday. Very good. So this would be 2. So it would be 2 times 2. So 2 groups of 2 plus our 3. Very good. So let's continue. And then it says, what does 2 parentheses n minus 1 mean in Sion's equation? So that's what we just talked about. It's 2 groups of these guys here. Very good. Are the equations that Zach and Sion wrote equivalent? Now, what does the word equivalent mean? What does the word equivalent actually mean? Yes. Yeah. Equivalent does not, okay, I'm just going to be very frank here. Equivalent means same value. It does not mean they look the same. That is another word in math. In fact, we'll talk about that later, but equivalent means that their value is the same. So if you think about a $20 bill and two $10 bills, those two are equal, but it is not, they don't look the same. Their value is the same, but they are not, they don't look the same. Does that make sense? So how would we know if these two things are equivalent? How can I tell if this is equivalent to this? What could I do? Yes, I know, right? Yeah. So you can look, you can compare the 2n. So see here, I see a 2n, but here I see a 3, and here I see a 1. Very good. Someone says, so all you'd have to do, Ms. Johnson, is simplify them to see if they're the same. Very good. So I'm going to simplify them, and I'm going to use my iPad because it's a little bit easier to do that. So I would be over here and probably more like this. Okay. So I'm going to set these two equal to each other. I'm going to simplify, sorry. I'm going to simplify this one to see if I can get it to look like this. So if I take 2, hold on. If I take 2 oops, it's doing funny things. Hold on, my iPad is, oh no, iPad, be nice. So if I take 2, really? Hold on, here goes. Here goes. Okay, if I take 2 parentheses n minus 1 plus 3, what would I do first to see if I get the same answer? Very good. Someone says if you get the same answer. So if I take 2 parentheses n minus 1 plus 3, what's the first thing that you would do to simplify this? What's the first thing that I could do for this? What would you do to this? Yeah, I would do this stuff in the parentheses. There's nothing to do inside. So then I would multiply, correct? I would distribute. Very good. So I'm going to distribute the 2 times the n and the 2 times the -1. So I get 2n minus 2 plus 3. Okay. Is everybody okay with distributing? Okay. Now what would I do? Very good. Now what would I do? I want this to look like this. So far I have the 2 n's that match, but this says 1. I want it to do 1. Yeah, but what do I do? What do I need to do? Yeah, just do -2 plus 3. What's -2 plus 3? Yeah, it's just 1. So 2n plus 1. Does 2n plus 1 equal to 2n plus 1? And that's an obvious answer. Yes, Ms. Johnson, they're exactly equal. In fact, they're exactly the same. Yeah, so -2 plus 3 is 1. Yes. So now I just proved that they were the same. So this equation was helpful to Zach because he went backwards, right? So he was comfortable with y equals mx plus b. This one was almost like they moved it forward 1, right? N minus 1, so they went forward 1. And then they had, how many were in there? Was now plus 3. So these are both the same equation. They're just represented differently. Okay, so like, for example, another way to think about this is like, I have a lot of people call me different things. So my name is Mrs. Johnson to you all, but my children call me mom. And then other people call me by my first name, right? So There you go. So Marcus joined the conversation and noticed, I was focused on the strip of blocks in the middle and looking for patterns 3 and 4. I think you could also write it as 2 times the quantity of n minus 2 plus 5 and 2 times the quantity of n minus 3 plus 7. So where is he getting this? Where is he getting these numbers? I'm trying to show you. Yeah, there. Sorry, it's so small because I really want you to look at this at the same time. Where are you actually? I'm going to snip it because it's too small. I'm going to snip this so we can just look at it normal. So where is Marcus getting all this information? Where do you see? So he said, I was looking at patterns 3 and 4. I know. Oh, so someone said, hey, why can't, since we already know Zach's method, why can't we just use that? There is an advantage. I will tell you, one of the things about math that that you will get comfortable as you go through the next 2 years of math is looking at something like this and being able to determine whether it's equivalent to this, or rewriting this so it's in its like different things, right? And so this happens quite a bit, right? Like if like have you ever told someone something and they're like, wait, what? I don't understand. And then you tried to tell them a different way and it's the same thing that you're telling them and they're not understanding. And then finally you tell them a different way and they're like, oh, I understand what you're saying now. So your ability to be able to say the same equivalent thing in different ways is very, very, it's actually really good, strong communication, right? Okay, so let's stare at this. And where do you see n minus 2? Where do you see the 5? Where do you see the n minus 3? And where do you see the 7? So here, your job is to look at where do you see all this stuff? Where do you see the 5 in this case? Where do you see the 7 in this case? Two increases. Okay, someone said 2 increase 5 is the next number of patterns. And then the next one says pattern 2, I counted 5 blocks, and pattern 3, I counted 7 blocks. Very good. Yeah. And so if you look at this is again the same, like here, this is Mrs. Johnson, this is mommy, this is Johnson, this is people calling me by my first name. Or if you want to do the $20 bill, this is $20, this is 2 10s, this is 4 5s, this is a 5, 5 1s, and a 10. You guys all see this is $20 in pennies. Very good. Yes, look for the pattern relationship between 3 and all of these numbers. Where do you see, how do you get this? So I'm going to give you another hint here. It says, Marcus joined the conversation and noticed this. I was focused on the strips of blocks in the middle. So he wasn't looking at the whole thing. He was just focused on this part right here, right? And that's how we got the 5. And that's how we got the 7. You guys all see that? Very good. Okay, so do you agree with Marcus? Are all these equations equivalent to Zach's equation? So I'm just going to multiply in my head really quick. 2n minus 4 plus 5 is 2n plus 1. 2n minus 6 plus 7 is 2n plus 1. So yes. So the answer is yes, right? So Sion says, oh, what's going on here? I'm going to look at the table to see if I can see why this is working. Sion made a table and noticed a pattern in the table and equations, the equations they had written. So here's 1 plus 2, 1 plus 2 plus 2, 1 plus 2 plus 2 plus 2, 1 plus 2 plus 2 plus 2 plus 2, right? Sion says, I used the pattern and I saw the table to write another equation. This time it looks like this: 2 times the quantity of n minus 4 plus 9, right? So where do you see the 2, 2, 2? Where are these numbers? Where do you see the 1, the 2, the 2, the 2, the 2 that Sion says in this in this pattern right here? Where do you see the 1 and the 2, 2, 2, 2, 2? Where do you see the 1? Where do you see the 1 and the 2, 2, 2, 2, 2? Added 2 and 1 is the start. Very good. So if you can imagine, this is the 1, right? And then they added 2 here, they added these 2, and then to get to the next one, they added 2 more. And then to the next one, they added 2 more. And this is basically how Ms. Johnson likes to write her tables, right? Broken down into their pieces. So this is the starting point. This here is pattern 1. This here is pattern 2. And this all the way to here is pattern 3, and all this is pattern 4. Does that make sense? So then Zach says, I don't even need the table. I think 2 parentheses n minus 5 plus 11 would give me another equivalent equation. Do you guys agree? Yeah, right? Because look, 2n minus 10 plus 11 would be 2n plus 1, which is the same. So examine the table and do the comparisons and explain how Sion might have been using the table when she found the equation 2 parentheses n minus 4 plus 9, right? Okay. So then we're good on those. So then it says use Sion's method to find an equation for each of the tables below. So this right here, right? So again, this is the table. If you extend it all the way out to 32, 33, 34, 26, 28, 29. So she's writing it like this, right? But she can shorten it up by writing it like this, kind of. So how would she write 50? How would Sion write 50? Okay, give yourself a second and think about how Sion would write 50 here. And then how she cut it short by writing it like this. Okay. Okay, so we're going to slow this down just a little bit, just so that we're all on the same page. We need to break this equation down to make sure that we understand where everything came from. Okay. No, not at all. So where does this 2 come from? Does anybody see a 2 that they want to talk about? What is the 2 called? Yeah, it's your slope. Very good. So this is your slope. So if you look at this, would you be able to find the slope? Everyone says, yes, I know how to find the slope, Ms. Johnson. Very good. Okay, n minus, that looks like a structure that keeps showing up over and over again. So we don't need to worry about n. We don't need to worry about minus because that's part of the structure. When I say structure, it means you'll see that over and over again. Okay, what about this 4? Where does the 4 come from? Let's change. Where's the 9 come from? In here. You're looking here in the yellow part. Where's the 4? Where's the 9? Yeah, the 9's the answer. So this is basically your y, right? So this is my y. Good. What's 4? Yes, it's the pattern number. Very good. Very good. So 4 is my x? Yes, ma'am. Very good. Very good. Pattern number included. Yes, sir. Does that make sense? Yeah. And someone else said, Ms. Johnson, 9 is the value for when n is 4. I got to clip that because that's powerful right there. 9 is the value. Where'd my thing go? Hold on a second. I lost it. There it is. 9 is the value for when n is 4. This is very true. So I need to copy this. So, right, 9 is the value for when n is 4. Let's put that right. Ooh, what did I do? Okay, oops. That doesn't help me. Okay. So, and then it says, I don't even need the table. I think the next one would be 2 parentheses n minus 5 plus 11. So would that be true? Would the fifth term have 11 squares in it? That's the question that he's saying. He's saying the fifth term would have 11. Is that true? Can I go like this? Can I do a 5 and 11 here? Is that true? Yeah, because if 4 is 9 and we're adding 2 every single time, that makes sense. It's 11. So does this equation now make sense? So let's review. Where did we get the 2 from? Who's 2? Who's 2? Where'd you get the 2 from? Very good. It's your slope. Okay. Then where did the 5 come from? Where did the 5 come from? Very good. 5 is your n or 5 is your x. Very good. 5 is your n or 5 is your x. Good job. So there's my 5 right there. 5. And where's my 11? Very good. 11 is my y, or 11 is my, my f of n, whatever you want to call it. Does that make sense? Okay. So we're all comfortable with this. Okay. Now I want you to build the equation of this. Is this from, I spoke wrong. This is not from if you continue this out. Okay. This is a completely different table. Okay. So now what I'd like you to do is pause really quick, and I'm going to have you pause. And I want you to find the slope, the x, and the y, and build me an equation that looks like this. So wait, Ms. Johnson, our equation's going to kind of look like that? It's going to look like y equals something, and then x minus something plus something. So I need you to fill in my somethings for this one and for this one. And I will tell you, there's a couple people that are gonna, if we all showed our equations to each other, which I will show you in a second, they might all be different and they will all be equivalent. Just like we were saying up here, Mrs. Johnson, mommy, and whatever, my first name is. Does that make sense? Okay. So I want you to do one for here and one for here. So can you fill those in while I build you a structure over here? So y equals blank parentheses. I know you guys were like, wait, Miss Johnson, I am lost. Yes, you're supposed to be lost in the very beginning of a lesson because this is your first time doing it. And I'm not, you all know this. I'm not going to be the teacher that says, and then put this here, and then put this here, and put this here. I'm going to say, wait, where did we get this from? And then you all tell me. Okay. All right. I'm going to pause the video really quick, and you guys are going to work on this for the next minute. Okay, so we're back. And so what I wanted to show you was step by step on how to find this. So the very first thing that we found earlier was we found the slope. And here for this one it was growing by 2 every single time. That's why this 2, that's why this 2, that's why this 2, this 2, this 2, that 2, all the 2s. Okay, all these had to do with the fact that it was growing by 2 every single time. Okay, so, okay, well, what about this one? What is this one growing by? Yeah, the slope is 5. Now, how did you get 5? Oh, I see. You're very good. Thank you for telling me. Plus 5 plus 1. So your slope is always going to be the rise, how much you go up over how much you go over. So that's 5 divided by 1, which is just 5. So far, so good on this. So far, so good on this. Good. Let's pause right here, right now. And then you tell me what the slope is here. Now, they tried to trick you. Don't let them trick you. Okay. There's a hint in here that I gave you that maybe some of you will see. You have to be very like attention to details in order to find the slope, because you can't just go boom, there it is. So find the slope on this. I'll give you another 3 seconds. All right, what's the slope on this one? Okay, absolutely. I like when you guys ask for more time. Yeah, I'm not going to fill in the rest of this right now, just because I want to make sure that we get the slope. Okay, give me 1 second. You guys a little bit more time to find the slope. The slope is they're trying to trick you here. Okay, so they're trying to trick you because anybody see what they try to do here in this table? Be like, use your very young, beautiful eyes to observe what you should have saw, but if you didn't pay attention to it, you would be tricked. Yes, they skipped numbers. Boom. And when they skip numbers like that, then your slope, you can't just pull off your slope like we did here. That's why I always pull off this guy. So our slope is going to be, so notice it's going down by 8, right? So that means negative. Yes, sir. And then this is going up by 2. So my slope in this case is going to be -8 divided by 2, which is -4. They tricked you, didn't they? I'm so glad that they tricked you when you got it wrong. And you guys are like, man, Ms. Jonathan, you're mean. Yes, but if you get it wrong and you understand why you got it wrong, you will get it right on the final, right? You'll get it right on the test. You'll get it right when it matters. So again, okay, so I put -4 there. Very good. There's my slope. So don't be fooled again. Yes. Do you guys want to do C as well while we're here to find your slope here? Yeah, let's do this one too. Okay, so let me put my little structure in. So this is y equals blank parentheses x minus parentheses plus blank. Okay, so here my slope is and my slope is. Just keep doing these little things here because that'll help you. Very good. I know some of you are like, Ms. Johnson, you sound really mean when you say, yay, I'm glad you got it wrong. But it's almost like that thing, right? Like, I'm glad you made a mistake when it doesn't count, like cost you, right? It doesn't cost you anything to be wrong here. Okay, so this one, yeah, someone said, Ms. Johnson, this is 7 for sure. And this is +1. So m equals to 7 divided by 1, which is just 7. So everyone's okay with my 7. Everyone's okay with slope, 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 slope. Everyone's okay with that. Okay, now this is where it matters. Now, again, we take an X and we put his Y right there. Pick any X you want. Any X I want, Ms. Johnson? Yeah, of the ones that they gave you, which one do you want to use? So someone says, I really want to use 3460. Okay, fine. Put 34 in the X spot and 60 in the Y spot. So that's one of my equations. One of my equations is 34 and 60. Another one of the equations would be the same thing, y equals to 5 parentheses x minus parentheses plus blank, right? Another one of these equations would be if I put 33 in the x spot and 55 in the y spot. Does that make sense? You have to put an x and its y. They go together. His x, his y, together. Does that make sense? Can you guys check your answers really quick? Check on these answers. So does everybody see why I put 34 and 60? Because you guys told me, oh, that's your X. Oh, and that's your Y. So does that make sense? So what's another equation that I could have written? Y equals 5 parentheses X minus what plus what? Yeah. Yeah, it takes a little bit of time. You guys can't expect to do things perfectly on the first time. I'm glad that you have a good expectation for yourself like that. But it's okay to stumble in order to run, right? That's one of the things. Yes, we need to put its corresponding pair. Very good. So I actually don't think about it like that. I just think this is the X and this is the Y. So no, someone said, so is this right here the difference between these two? No, this right here is this X. So this X and this Y. It could be of the first Y coordinate. Like if you wanted, if I put 32 here, you guys. Oh, I can't put 32 there. I'm so sorry, not 32. If I put 50 here. If I put 50 here, what would have to go here? If I put 50 here, what would have to go here? Yeah, his X. So this is the Y. Who's his X? Oh, 32. Make sense? No. No, the answer isn't 1. When I plug in, yes, I will. When I plug in 32, I should get out 50. Do you guys all see that? So let's plug in 32 here. You can plug in 32 here, or you can plug in 32 here. It doesn't matter. I'm going to plug it into here so you guys all see that it still works. So when I plug in 32 here, I get 32 minus 34, which is -2. -2 times 5 is -10. -10 plus 60 is 50. I did it right. All right, let's check on your work really quick. Let's see. This one. This looks good. This looks good. This is looking good. Whoever Richard Tapia is, awesome work. Who am I checking? I don't know who to check. This one. Okay, thanks. This one looks good. 5 is my slope, 3460, done. B is -4 is my slope. So I just need you to put in a point here and here. And same with thing goes here and here. Good job. Wait, am I on the right slide? Oh, here, this one. Yeah, so this one wouldn't be correct, right? Because look, if you're saying that 50 goes here, who's 50's X? Yeah, 32. But you're like, you should be able to plug in 32, right? Let me see what you put in the calculator. Oh, you didn't put it here. Well, you should be able to plug in 32 and you should get out 50. Yeah. Yeah. You should be able to plug in 32 and you should get out 50. Exactly. Okay, very good. Yeah. Someone else came up with a different analogy. Like, if you choose, I don't know, I'm going to use this person. If this person chooses to plug in here, they're using this point here, 70, you have to pick his match. So they're saying like, it's like a pair of shoes, Miss Johnson. Very good. Yeah, you can use the first coordinates. You can use the last. It doesn't matter. They still will be the same. Let me see if you fixed it. Or did you fix this yet? So you have to fix your X's, not your Y's look fine. It's just your X's. Yes, sir. Yes, sir. So again, I'm just going to plug in this. This is me checking during a final, right? So I'm going to like, oh, I want to check my final. Miss Johnson said to check during my final. So I plug in 32 because that's my X, right? Or even if you wanted to plug in this one, 34. So let's plug in 34. I'm going to plug in 34 and then it says -1. Oops, -1. Oh my gosh, Miss Johnson, type. And then plus 50. I should get out 50. But when I plug this in, I get 215. It's like, that's wrong. I should plug in 34 and I should get out 60. I said 50. I meant 60. I should get out 60 and I didn't get 60. So what does this person need to fix in order to get it right? Can someone help my friend Dorothy? What would this person need to fix in order to get it right? What would they have to fix here? No. In this equation right here, look at your equation, right? The X is fine. Leave the X alone. The X is supposed to be there, right? It needs to be a 32 here. Very good. So this right here, we need to, I don't know. I don't know how to like cancel out, but it needs to say like this. It needs to go y equals 5 parentheses x minus something. I'm going to leave some spaces there, something, and then they got this plus 50. Now, if I put a 50 here for A, who has to go in here? Oh, you changed it already. Good. Who has to go in here? Very good. A 32 has to go in here. Very good. So now you have this new form that you're working with that you can use over and over again. All right, so let's finish this off really quick because the bell is going to ring again. So what point would you like me to use here? What point would you like me to use here? Someone says use the first one. Okay, fine. I'll put a 26 here and I'll put a 78 here. Now look, your equation doesn't have to match my equation. Because look, there's 3 points to choose from, right? Oh, it's not catching up to me, so I'm going to scooch over. Again, which point would you like me to use here? Someone says, the middle one, Miss Johnson, you haven't used the middle one yet. That's fine. So I'll go -14 and 39. And then I'll clean it up a little bit, right? I'll clean this up a little bit because x minus -14 is a little bit sloppy. So I'll go with y equals to 7 parentheses x plus 14 plus 39. Does that make sense? Okay. So in order to build this equation, what do I need? What things did I have to have in order to build this equation? What things did I have to have? What did you guys tell me I needed up here? What did I need? Yes, I needed the slope. Very good. What else did I need? Very good. I needed an x and a y, which is also called a point. So guess what this form is called? Yeah, it's actually called the point slope form. Now you know why it's called the point slope form, because in order to build it, I would need the point and the slope. Or if they gave it to me, then I can pull off the point 14 or -14 comma 39 and the slope, right? Very good. Someone's like, it's called slope point formula, Miss Johnson, because the slope comes first. I don't know why, but it just doesn't like run as like smoothly off my tongue as much as point slope form. Okay, so for the rest of this lesson, now all you're doing is writing that equation over and over and over and over again. So your job today is to finish off this lesson and make sure that you're really, I'll use the word fluent with using point slope formula. So the actual formula looks kind of crazy. It's y equals m parentheses x minus x1 plus y1. Now, the reason why those little ones are there is that's a point versus an x and a y. So don't worry about that. That's just the placeholder. Put your x here, put your y here. Very good. All right. Thank you so much for listening.